Welcome to the next module. In the previous module, we actually went a little deep inside what a cricket score is and different aspects like on what conditions tampering becomes very difficult for people. And also, we discussed about how do we prove that a particular score of a batsman, is true, and how does the history of the entries will help in the sense right from the first ball of the batsman that he faced up until the last ball. If all the runs gives a sum of what is the final, then that is what it is. So coming to the next point, what do you think about that book? That is a book, like for example, a dictionary is a book, and a dictionary is a book that contains definitions for the words, right? So, in that way, what is a book called that contains the history of every event or the entries or the transactions and also has the final state of the transactions? And when you see this picture, what comes to your mind? What is that book called as? That begins with the letter L and ends with the letter R. And there is a 6 letter word. This is a 6 letter word which begins with the letter L and ends with the letter R. Yeah, it may not take much time for you. Of course, it is a ledger, right? So a ledger will have the sum of all the spendings or whatever, depending on the ledger, and also it will have all the previous transactions that were made, correct? Only then it's a ledger. If the ledger simply says, hey, this is the final figure, no, you may not call that as a ledger because it may not be useful for you in terms of checking where all the spending or earnings happened and all that, right? What if this ledger is distributed, the same copy of ledger is distributed to many people? Then it is called as a distributed ledger. And when we discussed that hypothesis, if someone tries to tamper the cricket score to prove that somebody scored some runs, what happens is it becomes a difficult task because that scorecard is distributed across many locations, many people. And in the same case, a distributed ledger, if the copy is being shared with many people, not just in the final stage, every moment an entry is made in the ledger, everybody gets to know about it, just like a cricket score. How it will be? How it will be, tamper proof. That's the beginning. This moment is the beginning of understanding the very basics of blockchain. Yes, from cricket, we have now jumped directly into blockchain. Welcome. Yeah. Now the word says blockchain. Now let's understand part by part. Now, what is a block? A block contains data, right? Data in forms of many transactions. Not just one, it could be many. And one part of block is data. The other part is a hash value. And it also has another hash value which belongs to the previous block. Okay, so a block contains one or more transactions. That is number one, and it contains a hash for itself and the hash of previous block. Now let's get to the next part. We saw that a block contains data, a hash, and also the hash of previous block. Now what is a hash? Hash function converts data of arbitrary length, in the sense any type of data, to a fixed length. This process is referred to as cryptographic hashing. As you may see in the picture, you will have a long string of data, right, which is like a hexadecimal data, hexadecimal hash, and this could be outcome of a simple name. In case of my name, if I just type Manoj and see what is the hash function of that, you could see a similar one that's coming up. Or if you just type hello, you also get the same. But if you change a single character, maybe from a small to a capital letter, the entire hash value will change. And this is run using an algorithm. In case of blockchain, this hashing mechanism of converting a data into a hash is done through SHA-256 algorithm. And this is a 256-bit algorithm, and this produces a 64-digit hexadecimal number as hash, which is highly difficult for somebody to hack. Now, why we need a hash? What if simply the data is stored and along with a password, just the way we have been, using email with a password? What is the need of having a hash for a block? That is something we will understand in the coming course. Now we just understood about what a block is. We understood a block contains data and there is a hash, and the hash is actually generated by getting all the data, putting inside a hash function. And in this case, we are using a SHA-256 hash function, and we get a hexadecimal, hash. And this is what a block is. And if you have a chain of blocks, okay, where each block is linked to the previous block, that makes a block chain. So each block will have data, okay, and each block is linked with the previous block, which means if I try to change any data, let's say the orange block, orange color block, which you are seeing before you, if I try to change any data, the hash value of that particular block will change, which means it will affect the next block as well. Imagine you're storing the cricket scores for each and every ball in each and every block here. Not just the score, you're storing every possible information. So blue color block number one, you're actually storing the ball number one bowled in that match, who was the batsman, what was the run scored in that ball, and number two, who was the bowler, what was the time, the date, the location, everything in each and every block for each and every ball. And if I have to tamper that, simply like using a password, it is not possible because any change in the existing block will affect the next block. So a blockchain is a distributed ledger. You may say a distributed ledger technology that stores information about transactions in a distributed manner in forms of blocks. Yeah. Now, what is distributed ledger technology? Now, I think you were able to link why did we discuss cricket score here and how is that linked with blockchain? A cricket score need not be a blockchain technology, but we just try to get some understanding of conceptual aspects of blockchain. First, distributed technology, it is distributed. Data on the blockchain is replicated across all the places wherever the ledger is seen, and synchronized. Synchronized, what does it mean? Any change made in any source will be reflected in all the other places. So data on the blockchain is replicated, shared, and synchronized among parties on a distributed ledger without the need of a central administrator. Unlike owned and managed databases, which we are using currently like RDBMS and other databases, blockchain provides an independent data sharing platform. And the next conceptual aspect of blockchain is immutability. It is immutable. This means once the data is entered on the blockchain, it cannot be deleted. Once a block is created in the chain and the hash function is created and it gets linked with the next block, along with getting linked with the previous block, it cannot be deleted or the information inside the block cannot be changed. So this makes a block immutable and hence the entire blockchain immutable. Edits can be made only by appending new or updated information, which again will become a new block. For example, block 1 says uh, ball number 1 of the match and a batsman has hit a 6. Yeah, a block is created and in the sense a score is already entered, but it goes to the third umpire and it seems like it was not a six, it is actually a boundary because the ball just landed before the boundary line. So what happens is, just to compare with the blockchain scenario, you will not delete that entry, but rather you will say another block that the previous uh, decision of a six for that batsman is not valid. Now it is actually a boundary, and this change in the score happened through referring to the third umpire, and the third umpire was this person, and it happened at this time and this date and all that for each and every block. So this means you have a permanent record or audit trail for all the data entered. See how detailed it is when it comes to having the history of record. You know every bit of it in a blockchain, and it is digital. Now you might imagine that if there is a blockchain solution, many people are actually involved in that. No, not necessarily. As we proceed further in this course, you will understand that it is mostly machines that is doing this job. It is digital. This is what I mean. While not unique to blockchain, of course, digital is something used everywhere. It's important to know that all data or processes and transactions are progressively become digital. It should be less of humans and more of machines or devices, which will make some sense for the businesses. Why should we employ or deploy more people to do something while we are actually aiming at reducing cost and increasing efficiency? So this is a lot of digital involved here. So let's have a quick summary of where we have reached. A block contains one or more transactions with a hash value for itself and also the hash value of the previous block. So that's a block. Hashing is a hash function, or hash function you might say. Hash function converts data of arbitrary length in the sense it could be of any length randomly, to a fixed length. Okay, and this function is done through a algorithm called SHA-256 algorithm, which is a 256-bit algorithm, and it produces a 64-digit hexadecimal number as hash. I'm sure you remember that any minute change, any change for that matter, within the data will change the hash value entirely. You may in fact experiment this in websites that are that will show or will generate a hash value for any character using SHA-256 algorithm. You may type your name and check with all small letters what is the hash value, and then you type your name again with one character in capitals and see what is the hash value. You may experiment that. And blockchain, a blockchain is a distributed ledger that stores information about transactions in a distributed manner in the form of a block or series of blocks. And importantly, the blocks are arranged chronologically in the sense block 2 will have data about transactions that happened after the transactions in block 1. It is not randomly arranged. It has some sense the way ball number 2 in a match gets bowled after ball number 1. It is not otherwise. Or ball number 4 doesn't get bowled after ball number 1. It is always 1, 2, 3, 4 that way. It is chronologically arranged. So if you go and trace block by block, it will make some logical sense and also chronological sense. Coming to next, distributed ledger technology. It has data on the blockchain that is replicated, shared, and synchronized. Synchronized is the word you must try to understand again clearly. It is about data getting reflected among all the parties at the same time, not just later. Yeah. Immutability. This means that once data is entered on the blockchain, it cannot be deleted. Edits can be made only by appending new or updated information. With blockchain, you have a permanent record or audit trail of all data entered. Imagine a situation, use blockchain for managing your supply chain, and you happen to enter a supplier's information where you got the name wrong. Yeah, and you have to edit it and you have to enter it again. Nothing wrong happens, but what will happen is the fact that on the first entry the name was entered wrongly will be registered in a block, and then you can add always another block that will say that the correct name and in correct order. Yeah. So now we have used cricket as an analogy, and we have understood a certain aspect like what is a ledger. Ledger means it has all the transactions. There is nothing important or less important in that. Every transaction is recorded. That is what makes a ledger. And when it is distributed across many parties where every person gets to know or every party gets to know the updates on the same time, then it becomes a distributed ledger. And if it is done through technology, then it is a distributed ledger technology. Yeah. And we also learned about immutability, hashing, hash function, and blockchain with reference to cricket. Now let's get into business from the next module.